Hi, dual enrollment folks. This is section 1.5 and I'm Ms. Backfish and I'm here to go over some of the topics that you expect to see in this section. This section has a lot in it, honestly. It has almost kind of a whole unit that might be in an Algebra 2 class in high school on quadratics. And that's really what this whole section is about, is quadratic equations, specifically solving them. So maybe if I had room there, I would put the word solving quadratics. How about solving quadratics? And there are really three things you're asked to do with quadratic equations in this section. You are asked to solve by factoring. You are asked to solve by the quadratic formula. And you are asked to solve by the square root property. Those are the three things. Not in that order. It's actually factoring first, square root second, and quadratic formula third. So this is an example of a question that comes up early in the homework, is a question like this. It says, use factoring to solve. Check by substitution by using a graphing utility. So we're going to talk about what that means in a second. But first, I want to talk about just factoring in general. So let's just remove these problems and just do a quick overview of factoring in general. Okay, so when we are factoring, here's the order in which I would ask questions. Number one, is there a greatest common factor? If there's a greatest common factor, go ahead and pull it out. In other words, if I have 3x squared plus 6x plus 12, then take out that 3. And then you can see about factoring what's left inside the parentheses. But if there's a GCF, first things first, take that out. Sometimes that's as much factoring as you can do, and that counts as factoring. So you would stop there. Okay, here I might be able to go further, but sometimes, like let's say you have, let's say this is your expression. Well, if I take out a 6, I'm done. I can't go any further. Okay, so that would be fully factored. The next thing you want to do after you take out your GCF is you want to say, how many terms am I trying to factor? How many terms are in the polynomial that I am trying to factor? Okay, if there are 2 terms, there are only a few ways to factor something that has 2 terms, meaning a binomial. If it's a binomial, one way is what I just did right here, taking out a greatest common factor. Another thing is it could be the difference of squares. Remember, the difference of squares is if you have a squared minus b squared, then it factors as a plus b times a minus b. Like maybe x squared minus 9 is x plus 3, x minus 3, and it really doesn't matter if you put the plus or the minus first. So it could be the difference of squares. Or another option is it could be the sum or the difference of cubes. So you see if the first and the second terms are both things that are cubed. Could be the sum or difference of cubes. Those are not as common, but those also have sort of formulas we like to use. This one is, hopefully I will remember this correctly. And this one. Okay, so when I say there are 2 terms, there's basically 4 options. It only has a GCF, and that's all I can do is take out the GCF. It's a difference of squares, something perfect square minus perfect square. It's the sum of 2 cubes, something cubed plus something cubed, or the difference of 2 cubes, something cubed minus something cubed. If it's none of those 4 options, 1, 2, 3, 4, then it can't be factored any further. Like here, that has 2 terms. It's none of those things. I'm done. All right. Now, what if it has 3 terms? If it has 3 terms, remember we call that a trinomial. These are some of the most common factoring problems. Generally, if there are 3 terms, we usually look at something that is in a quadratic format. Okay. Obviously, we still always want to start with, is there GCF? If there is, great, take it out first. If there are three terms and either there's not a GCF or there is, but we already took it out and we're still wondering about factoring what's left over, then here's the next thing we need to look at. Okay, and usually it's going to be something that fits this format. Okay, now it's possible that it wouldn't be, but the vast majority of the time it's going to be, so we're going to talk about these. Then the question becomes, do we have a leading coefficient or not? In other words, is this first number 1 or is it something else? If it's 1, we don't see anything out there. It just starts with x squared. Okay, that's something like x squared minus 9x plus 20. That's when a is 1. The leading coefficient is 1. The other option is a is not 1. That's like if we have 3x squared minus 7x plus 10, something like that. All right, so that's the next question we ask if we have 3 terms, is which of these is the case? If this is the case, that's the most simple type of factoring that we usually think of, and that's the ones where we go find 2 numbers that multiply to give me this bad boy, the constant term, and add, same 2 numbers have to add to give me this. That's called the coefficient of the linear term. It's basically the b. So they have to multiply to give me c and add to give me b. So here that would be -4 and -5. And then I can go ahead and write it in factored form. I could just write x minus 4, x minus 5. When you're factoring a trinomial like one of these, your answer is always going to be 2 binomials. Okay, now this one I actually did not even check to see if it could be factored, so let me look at it for a second. Okay, when I made this up, I wasn't actually planning to factor it, but it turns out that it's really close. Let's go ahead and make this negative, and then it will factor. Okay, now the way we factor, if we have a leading coefficient that's not 1, the way we factor a trinomial then is generally called grouping. There's lots of ways to describe it, and there's lots of different visual ways to do it. Sometimes people do it with a little symbol like this. Sometimes people do it and call it the box method. They do something like this. But they're all just more visual versions of what I'm about to do for you right here. Very first step is I multiply the first term and the last, or the coefficient of the first term and the last. So a times c. A times c here is 3 times -10, that's -30. So I need 2 numbers that multiply to give me that. Over here, remember, it was multiply to give me c. But here we're going to multiply to give me that, and then add to give me b still. So I need 2 numbers that multiply to give me -30 and add to give me -7. And those 2 numbers would be -10 and +3. And it's a coincidence that those 2 numbers are already here. And so what I'm going to do now, I take those 2 numbers, and I'm not ready to just jump to the end like I was in the last one. Now I have to take those 2 numbers and split up the middle term into those 2 numbers. Instead of -7x, I'm going to have -10x plus 3x, which together does add up to -7x. And then over here I've got bring down my plus -10. The whole point of what I've done so far is to get 1, 2, 3, 4 terms. This is called grouping because what we're about to do. We're about to group these in pairs. You can't group pairs unless you have 2 pairs. Okay, so grouping counts on having 4 terms. We're going to come back to that in a second. So let's say, I'm looking for a different color. This is where I group. I group right here. Now, one thing to be aware of here is that I always want a plus in the middle here. If there's not a plus in the middle, if it's a minus, I move it over and I let it be a negative for this guy, and then I put a plus. So in other words, instead of, if it said -3 there, I would make it plus -3 and put the negative inside parentheses. Okay, now I'm going to take the greatest common factor out of the first set. The greatest common factor here is x, and that leaves me with 3x minus 10. The next set, I'm going to take out whatever allows me to leave the same thing inside. These 2 that I'm pointing at have to match, always have to match. It just so happens that's what this already says. So if there's nothing to take out, I'm just going to say plus 1. I do need to put something out here. Okay, and finally, I'm ready to write my answer here. I'm still going to have two binomials like this, two sets of parentheses. One of them is going to be whatever's already in parentheses above here, these two. And then it's kind of like I have canceled that out or taken it out. And then whatever's left, x plus 1, that goes in the other set of parentheses. What we're doing there is kind of like distributive property in reverse. We are undistributing this. Instead of putting this on the x and this on the 1, we're taking it back. That's my answer. All right, the last question here, or the last thing to talk about, it says how many terms are there? We said 2, we said 3, we haven't said 4. What if there are 4 terms? Well, if there are 4 terms, then I jump to this step. I just go ahead and use the grouping, like I just taught you, that we used with 3 terms. But what we did with 3 terms was we went through this process, A times C, found 2 numbers that multiplied to give me that product and added to give me the B. And then I split up the middle term, and therefore I got 1, 2, 3, 4 terms. If you already have 4 terms, you're already on this step, and you're ready to draw those parentheses I drew in green. Okay, and then you go exactly like that from there. Same thing. Okay, so having reviewed factoring, I'm going to have to make a cut there. I'm sorry, I thought I hit pause. If I don't make a cut there, I apologize. Having reviewed factoring, I'm going to look at this one with a critical eye and say, does this have a greatest common factor? First question. No. There's not an x in every term. There's not a 3 in every term. No. No greatest common factor. Next question. How many terms are there? 1, 2, 3. Okay. So next question is the leading coefficient 1 or not? Yes, it is. It's 1. If it's 1, all I have to do is find 2 numbers that multiply to give me this, and the same 2 numbers have to add to give me this. Those 2 numbers, let's see. What 2 numbers multiply to give me negative 28 and add to give me negative 3? That would be negative 7 and positive 4. Be very careful of your signs. Very careful of your signs. And then I have x minus 7, x plus 4. If you're not positive you did it right, check it. You can do FOIL and multiply this back out, or distributive property, and make sure that you get this. Now, we're supposed to be solving. Solving is more than just factoring. This is factored. Solving is when it's equal to 0, and I say, okay, I want to know what x value makes this equal to 0. So now I'm going to go ahead and I'm going to set each of these equal to 0. This is called the zero product property. It says if something times something else equals 0, then one of those somethings has to be 0. So either x minus 7 equals 0 or x plus 4 equals 0. So either one of those would make it happen. So if x is 7, that'll equal 0. And if x is negative 4, that'll equal 0. So those are my 2 answers. Most of the time with a quadratic, you're going to have 2 answers. So check by substitution or by using a graphing utility. So let's do substitution first. Okay, so I'm going to plug back in 7 up here. 7 squared minus 3 times 7 minus 28. That's 49 minus 21 minus 28. Is that 0? Yes. Then I'm going to check negative 4. Let's do this. Negative 4 squared minus 3 times negative 4 minus 28. That's 16 plus 12 minus 28. Is that 0? Yes. So I checked by substitution. Now let's go ahead and talk about graphing utility real quick. When I graph a quadratic, I get a parabola. The reason most quadratics have two solutions is because a solution is asking you what x values make the function 0. The function is basically the y value. Okay? In other words, they're saying, when are we here? What x values give me a 0? So they're asking you where it crosses the x-axis. So that's the same thing as asking for the x-intercepts. If I have a parabola, since it turns around like a boomerang, that's why most parabolas, or I wouldn't say most, but many parabolas, cross the x-axis twice. Some of them, let's pretend I got a little closer, hit it once and that's it. That would be if the vertex is on the x-axis. Some of them don't hit it at all. So those are the three options. If I have a parabola in terms of x-intercepts, I either have 2, 1, or none. But a lot of the time I have 2. Now, really, any which way it works, though, I usually have 2 answers. Because even if this is the case, what we usually call that is a double root. And what happens here is I have 2 imaginary roots. Okay, so let's go ahead and look at the graphic checking. Okay, so this is not a beautiful one to show you on because it doesn't actually look like a parabola. And the reason it doesn't look like a parabola is it is so tall, or so skinny and tall, that it doesn't really look that rounded. But you can still see that it crosses the x-axis in 2 places. One of those 2 places is -4 and the other one is 7. So that's exactly what we're doing in terms of checking using the graph. Okay, so let's do a few more factoring ones. So this says, assuming it has the same direction, solve by factoring, check your answer, blah, blah, blah. Okay, first question, is there a greatest common factor? No, nothing goes into 21 and 11 and 2. And there's not an x in every term either. So nope, greatest common factor is not there. Next question, how many terms do I have? 1, 2, 3. Okay, it's 3 terms. So then my next question is my leading coefficient 1 or not? It's not. This is when I need to go ahead and take my 3 terms and turn them into 4 for grouping. All right, so the first step there, remember, is multiply 21 times -2. That gives me, that's A times C. 21 times -2 gives me -42. So then I'm going to come over here to the side and say I want 2 numbers then that multiply to give me that, and add to give me the coefficient of that middle term. So 2 numbers that multiply to give me -42 and add to give me -11 are -14 and 3. Okay, so now I take those 2 numbers and I'm going to split up the middle term into -14 and 3. -14x and 3x, because remember, these 2 terms have to add up to be that. So they need the x. Bring this guy down. Okay, and I'm ready to group because I've got my 4 terms. So I'm going to group it in pairs, and I have a plus in the middle, which is what I want. And then I'm ready to take the greatest common factor out of these 2. Well, there's an x both places, and 7 goes into both of those. So I'm going to take a 7x out, which leaves me with 3x minus 2. And this one, again, is already set up that way, so I can just say plus 1 times 3x minus 2. All right, I'm not done yet. My final thing is to write that as 2 factors. My 2 factors, one of them is whatever's already in parentheses. And then it's kind of like I've used that, and so I can mark it out now. And everything I haven't used goes in the other set of parentheses, 7x plus 1. All right, so that is what I am saying is equal to 0. That is the factored form. Once I have it in factored form, this is when I say, let me set each factor equal to 0 and solve. So if 3x minus 2 equals 0, that would mean that x is equal to 2/3. So 2/3 would give me 0. The other thing that would give me 0 is if x is equal to -1/7. So those are my 2 solutions. And again, you can check them by plugging in. This would be a great time, in my opinion, to go ahead and use a graphing utility because plugging in fractions is going to be a little messy. And I'd rather not do that if I don't have to. Okay, next up. How about this one? Okay, now A problem like this very often throws people off track. Okay, they look at it and they're like, I don't know what to do. There's not 3 terms. That's why we have our list, our checklist. Number 1, is there a greatest common factor? Yes, there is. 3 goes into both of these. X goes into both of these, so 3x can come out of both. And when I take a 3x out, I have x left over here and 5 left over here. So now I've got it in factored form. This is factored form. I always want to check with something that has 2 terms and see if what's left in the parentheses, could this be factored further? Is it a difference of squares? Is it a sum of cubes? Is it a difference of cubes? All of that's a big no. So I'm ready to solve now. Keep in mind that what's out front here counts as a factor. Okay? If it doesn't have an x in it, it really is a factor that doesn't matter. Because remember, the idea here is if this times this equals 0, then one of these things must equal 0. If it just said 3, well, 3 doesn't equal 0, so it doesn't matter. But 3x can equal 0. So I need to see what's going to happen here and say, oh, x equals 0 would work. And then over here, x equals -5 would give me 0. So those are my 2 x-intercepts here. This quadratic crosses the x-axis at 0 and at -5. Next, we have another trinomial, sort of. Let's do it here. Trying to conserve paper. Let's say that I have this. Okay, reminder that all of this is based on the idea that we're looking at something that's in standard form, that ax squared plus bx plus c. If it's not there, which it's not, we need to get it there. Besides which, anytime we're trying to solve, we really need to get it so that everything's on one side and the other side is 0. Get it all equal to 0, because that's how we use the zero product property, is if we say all of this is equal to 0. So let's go ahead and do that. All right, now, greatest common factor, nope. 3 terms, leading coefficient is not 1, so I'm going to use grouping. So first I do 5 times -6. That's -30. I need 2 numbers that multiply to give me -30 and add to give me -13. Don't get tripped up on this one. I want you to think for a second what they could be, because there's a common pair that you might stumble over. It's not going to be 10 and 3. There's no way to make the signs work. You have to be very careful about signs. Okay? The only way to make the signs work is -15 and +2. So I'm going to split up the middle term as -15 and +2. And remember, because I want that plus in the middle, that's why I chose this order. If you did it in the opposite order, it would not be a big deal. If you said 5x squared plus 2x minus 15x minus 6, it's not a big deal, but remember we want the middle term to be plus, so I would basically move that minus over as a negative with this guy and put it inside the parentheses so that it's plus right there in the middle. Okay? It would make our answers, it would make our work look different along the way, but we would still get the same answer if you traded these two. So now we're on the grouping. The greatest common factor here is 5x. That leaves me with x minus 3. And over here, I also need x minus 3. These always have to match. If you can't make a match, you can't factor it this way. So that's a problem. So I need to figure out, what do I take out of this to leave x minus 3? And the answer is 2. And now I'm ready to write it in factored form. 5x plus 2 times x minus 3 equals 0. If I set each one of those equal to 0, I'll get -2/5 and 3. If you don't believe me, set them equal to 0 and find out. All right, last one, we're going to do factoring. Okay, again, remember, if we are not in standard form, we have to get in standard form. So let's go ahead and get this. That was just distributing. Move everything to one side so that I can call the other side 0. Because if you subtract everything from one side, that's what you have on that side is 0. So minus 3x plus 9. Sorry that this is bled through. Okay, 11 times 9 is 99. Wow. Okay, so I'm looking for two numbers that multiply to give me 99 and add to give me negative 13. Let's see. I have to think about that for a sec. Okay, so I'm having trouble coming up with my numbers. So what happens when you're having trouble coming up with your numbers? Well, let's find some strategies. Okay, so I'm going to take 99 and I'm going to think about factors of 99. I'm going to make myself a factor tree. 9 times 11. Okay, 9 is 3 times 3. So the prime factorization of 99 is 3 times 3 times 11, because all of those are prime numbers. Now here's the deal about that. If you find the prime factorization, every set of factors comes from there, from combining things that I could put together here. Like in other words, these two together times 11 is 9 times 11. Or I could do 3 times these two together, 3 times 11 is 33. So basically 33 times 3 or 9 times 11 are my only pairs of factors that are going to make 99, and none of those are going to add up to 13. What to do? Well, if something doesn't factor, there's a special word we say. So if this doesn't factor, we're going to use that special word and we're going to say it's prime. Okay, so doesn't factor, does not factor, or there are no factors. Now let's look at what MyLabs does with that. Okay, y'all are going to love this. Look at what I did. Right here. I wrote the problem down wrong. That's why mine doesn't factor. Theirs must factor. It's truly viable for them to give you one that does not factor. I was just wanting to make sure I knew what they told you to say there. You could say empty set. I don't see the word prime, so I would say empty set. But this one probably does factor because this is not the one I did. So if you look at what's up there and then look at mine, the x is missing right here. Okay, so it should be 3x squared minus 9x. So let's see if we can go from there. This is, let's move everything over here. Subtract 3x squared from both sides, I get 8x squared. Add 9x, I get minus 1x. And it's equal to 0. So now I'm going to take a greatest common factor out of those guys. And I get, let me put that x in there. I get x equals 0 or 8x minus 1 equals 0, which gives me 1/8. So it looks like 0 and 1/8 are my two answers. So let's head back over to MyLabs and check that out. Okay, so I'm going to type them in with a comma. It says use a comma to separate answers as needed. So comma, and then I'm going to go to fraction, and I'm going to say 1/8. I want to say, just to let you know, pretty sure, yeah, if all I did there was I just tapped the division bar at the top of my numeric keypad, right next to where it says, it's like the slash mark, and it does turn it into a fraction for you. Well done, me. It's so good when you write the answer down, write the question down correctly, isn't it? Okay, so the next thing they ask us to do in this section is to solve using the square root property. So here's what they mean. They mean solve by taking the square root of both sides. That's all they mean by that, is solve by taking the square root of both sides. What you will notice about this equation is that there's no linear term. There's no just plain x. There's an x squared, and there are constants, but there's no plain x. If there was a linear term, if there was just an x term, we couldn't do it this way, okay, unless we completed the square first. So with square root property, if you don't see an x term, it's a good time to use it. It's actually probably going to be simpler than using the quadratic formula or factoring if you have that scenario where you have an x squared maybe, or multiple x squareds you could put together, and then you have numbers, but nothing like 3x or negative 7x, nothing with just plain x. So this gives me x squared equals 3. Okay, now, when we take the square root of both sides, we have to remember plus or minus, because we have to remember we're going to have two solutions. Okay, so we're going to do plus or minus. We're going to put that out front of the radical over here on the right the second we put a square root on both sides. So we have x equals plus or minus root 3. And that's our answer. Now, on MyLabs, they don't give you a plus or minus button. So what you have to do is you put in square root of 3, comma, and then negative square root of 3. Okay? Let's do another one like that. Here's another one that is well set up for us to use the square root property. And when I mentioned, by the way, completing the square is how I would get it like this. You are not asked to do that in this section, so don't worry about it. They don't ask you to use square root unless it's already a complete square. Okay, so that's the situation here. Now, why am I dividing by 2? Because the first thing I want to do is I want to get the squared part alone. That's always the case. I want to get the squared part alone. And then I'm ready to take the square root of both sides. I'm displeased with my marker situation. Let's see if this pink will show up. It's not too bad. And that gives me the plus or minus, don't forget that. And now over here, I don't have just x, I have x minus 5. Comes out from under the radical. And on the right, I have plus or minus root 5. So you haven't solved until you have isolated your variable. We still have to get x alone. So we're going to add 5 to both sides. But what we like to do is we like to squeeze it up in here. So we're going to put it right up there. I'm not going to put it in the back. I'm going to write x equals a positive 5 plus or minus square root of 5. Okay? This is kind of like the complex number situation where we want the real part first and the imaginary part second, that kind of situation. This isn't imaginary, but it is irrational. So we like to put the rational part first and then the irrational part second. It's just sort of a convention, just the way we tend to do it. Remember, please, that this is two solutions. And if we don't have a plus or minus button, that means we have to input it as 5 plus square root of 5 and 5 minus square root of 5. All right. Last square root one I want to work for you is right here. Now, if we were working in a situation where we had been told we were only going to use real numbers, I would look at this and go, oh no, there's a problem here because I'm not going to square anything and get a negative. But we have progressed beyond that day. We are now working with imaginary numbers as well. So we're going to go ahead and solve this. The squared part is already by itself, so I'm ready to take the square root of both sides. So x plus 8 comes out over here, equals, so I'm going to go ahead and just write this more pretty. This is what I've got. Remember that a negative under the radical comes out as an I. So if we're thinking just one step at a time, this is what I have. But square root of 25 is also something I can take the square root of, or it's also a perfect square. And so that becomes 5. We usually write that in front of the I. So this is what I have. And everything's done except for one last thing, which is, don't forget, x is not alone. So subtract 8 from both sides. And I'm going to put it in front. I'm going to stick it up in there and say x equals negative 8 plus or minus 5i. And that bell you heard was me getting the problem right. Not really. Okay, last thing to look at in this section is the quadratic formula. Solve using the quadratic formula. Here is our friend, the quadratic formula. The quadratic formula relies on us being in standard form. Remember, standard form is ax squared plus bx plus c. It relies on that because that's what those letters stand for. They stand for the coefficients of this expression when in standard form. So we have to go ahead and move this 6 so that we have standard form on the left and 0 on the right. And now I say that A is 5, B is -7, and C is -6. So now I'm ready to plug into the quadratic formula. Here's what I want to tell you about the quadratic formula, folks. The great thing about it is it always works, okay? Factoring does not always work. Some things are prime. Some polynomials are prime. They cannot be factored. Solving by taking the square root is not always set up well to work. You could always do it because you could always complete the square, but sometimes that would be really messy. So taking the square root to solve is not always the most convenient thing to do. Quadratic formula always works. However, it's also always messy, okay? There's a lot of details in there that you can get wrong, and people do. If I walked into any college level calculus class and asked everybody in the room to do a single quadratic formula problem, I guarantee some of the people in the room would get it wrong. Just because there's so many little details you can overlook and mess up your sign or something. So let's be very careful about this and very intentional about it every time we use it. And so every single time I use it, the first thing I do is write everything in the quadratic formula without doing any simplifying whatsoever. In other words, opposite of B. Well, B was -7, so now it's +7. Plus or minus square root -7 squared. To be perfectly honest, sometimes I do that. Sometimes I go ahead and simplify that when I first write it. But I just told you I never did, so we'll just go with that. Minus 4 times A times C. This is the number one place for people to make errors here. All over 2 times A. Okay? Here's why this is the number one place to make errors. You're multiplying 3 things, and basically one of them is negative. It's like that 4 is negative. If one of these is also negative, we're not going to be subtracting because a negative times a negative makes a positive. So we're going to be adding everything under here. Now, if both of these things were also negative, then we would have negative, negative, negative. It would be still negative. But you have to be very intentional about those signs, okay? So we have 7 plus or minus the square root of -7 squared is 49. 4 times 5 is 20. 20 times 6 is 120. And because of the minus and the negative, it's plus. All over 10. Excuse me. I'm doing too much talking. So these two add up very nicely into a perfect square. 169 is the square of 13. So that's 13. And now we do both things it's asking me to do. Plus or minus means do it with a plus, and that's one solution. Do it with a minus, and that's another solution. In other words, 7 plus 13 all over 10. 7 minus 13 all over 10. 7 plus 13 is 20. Divided by 10 is 2. 7 minus 13 is -6. All over 10. Let's simplify it and get -3/5. Why am I doubting myself there? 7 minus 13, that really is -6, isn't it? Yeah. Okay, so those are my 2 answers. The big thing with quadratic is just be careful. Just be very intentional and careful. Look how much work I showed. It's not something to try and do much of in your head. Okay, the more you do in your head on quadratic formula, the more likely you are to get it wrong. Okay, so I hope this has helped you remember how to solve quadratics by factoring, how to solve quadratics by taking the square root, and how to solve quadratics by the quadratic formula. Thank you for joining me, and I'll see you next time. Bye.